Okay, welcome to the next video that follows. So in this video, it's a continuation from the last one, right? After completing the table, you've inserted your uncertainties. The part that then follows is plotting a graph. So we're going to start with this by looking at a simple example. And if you're following along, I hope you have access to this paper. You're also trying it alongside with me. That way it's more fun when we both do it together. So my example is always as follows: May, June 2022, question paper 5-1. So this question comes with 4 marks, right? So the thing I like about paper 5 is so predictable. Once you master the formula for one paper, you can basically solve any paper because it's almost the same, right? So the 4 marks are as follows. Number 1 is for plotting the graph. So putting your points and plotting them in, you're going to get 1 mark. The other one is for inclusion of error bars. They have to be plotted correctly for you to get this mark. The other one is drawing the straight line of best fit. So we're going to understand in this video what exactly is the straight line of best fit. And if you need help in further drawing that, you can also ask for a video separately just for the straight line of best fit. I can also make that for you. And the worst acceptable straight line on your graph. And the goal is for you to label both of these lines. So those are the 4 marks that we're going to cover in this video. And after this video, you should be able to get this mark correctly. So first, let's start on plotting error bars, because plotting points really is just you finding points that you're going to plot. For example, the first point is 0.15 and 0.68. All you're just doing is going here and saying 0.1, 0.5, and saying it's over here. You go over there where they meet, you put a cross, right? You shouldn't put a blob, you shouldn't do like a big circle, just put a tiny little X that's half the small square. So you can see that if I zoom in, this is a full box, okay? So essentially I should make sure that my X is like this, right? Half of the small boxes, you should just try to leave within this range, right? Half on the other side, half on the other side, half above, half below. That's the point that you should plot. Very, very small. So before the exam starts, you need a very sharp pencil to ensure that you're able to get this mark correctly. Okay, so first let's understand what an error bar actually is. So it's a graphical representation of the uncertainty or the variability of data points on your graph. So it helps us indicate how your measured values deviate from the true value due to experimental errors, right? An error bar basically tells you the range where the true value will lie, either in the x-axis or in the y-axis, because you're human and you're bound to make errors. So what am I saying? What I'm saying is, if you have this graph and you see this little line over here, this is telling you that the person who made this measurement was very uncertain. So their true value lies in this range, right? They're not sure that their true value of log m is actually where they plotted. So they're giving you a range to say, my answer could be over there, but it's falling within that range. That's what an error bar actually is. So error bars are very important because they show the reliability of your measurements. You're saying, I'm human, right? I'm going to make mistakes. That's normal. Here's how I've accounted for that. They help show accuracy because if they're very large, it means you're more uncertain. So I can see this person wasn't so accurate. But if they're very small, it shows me that it's more accurate. And they also help you in plotting the line of worst fit, which you're going to see very soon. So how do you actually draw them? We have 2 types of error bars. So 2 types of error bars. They are horizontal error bars and vertical error bars. So those are the 2 types. And how you draw it actually determines with the nature of the question. If they ask for uncertainty in the value that's going on the y, that's what you do. If they ask for the uncertainty in the value going on the x, that's also what you're going to do. So a horizontal error bar is basically a straight horizontal line like this, right? That's basically what a horizontal error bar actually is. A vertical error bar, however, is basically like this, right? It's showing that the actual true value is not actually this. Maybe it's here, maybe it's there, right? Or maybe it's here, maybe it's there. I don't know. And it's up to you to make sure that you actually plot this. So for example, if I have x is equals to 4.0 plus or minus 0.2, what's happening is you put your x, right? Then you go above, you draw a line going up, and then that line should be of length 0.2 to show your uncertainty. Then you do it downwards over here. It's also going to be 0.2, but in the negative direction going down. Then you draw this little cap. I like to call it a little cap, right? Very, very small, a tiny little cap, and it should be done. If it's a horizontal error bar, again, this will be 0.2. You're literally looking at your axis and drawing that. This would be 0.2. And again, you put your little caps at the end, right? So in the previous question, you saw me drawing the horizontal error bars that I was supposed to include. So that's where we're going to get at when we just use that question as an example. So I just want you to learn first before we can actually solve a real life problem. Okay, so after understanding how error bars are plotted, you have your points plotted, you have your error bars present. What's left is drawing a straight line of best fit, right? So a straight line of best fit is basically a line that represents the trend of data points. It really does not have to pass through all the points, but should be as close as possible to most of them, balancing the points above and below it. Again, don't overthink it, just draw a straight line that achieves the balance of points, and the line should pass through certain points. Remember to label this line like I did in green on the graph. So I drew here and I labeled it over here. Okay, so what's a line of, right? A line of best fit is basically saying, I give you a bunch of points, right? 1, 2, 3, 4, 5, 6. Okay, a line of best fit says, what line can you draw that ensures even distribution of points above and below? That's basically the goal of a line of best fit. So if I were to draw something like this, I can't. Because if you look at this, they're like 5 points down and 1 point above. It doesn't make sense, right? So my goal is to say, how can I even out these points? I could do something like this, right? So something starting from here, going over here, like this, right? So you can see I have 2 points above, 2 points below. That's a line of best fit. It's a line that best fits the points that you have. That's basically all that it is. So it has to pass through certain points. Now, you don't know these points, the examiner does. So just make sure that you have an even distribution, and to get this mark, the examiner just looks at the different points that you have and tries to evaluate if your graph is correct. But it's out of your hands at this point. What you just do, look at the points and you plot the line of best fit. Hope that makes sense. The line of best fit, however, is basically saying, okay, you have a line of best fit, right? But maybe it's wrong, right? So you want to give it a range in which the line of best fit can lie in, again, because you're uncertain. So you're going to have this range that's present over here, right? And it comes from drawing the lines of best fit. We have 2 lines of best fit that you can draw. So the first one, it can touch this point over here, then it goes straight, then it touches this other point over there. So it's like top left corner on that side, and then the top left and right corners, basically. So essentially, this is the worst acceptable line, right? It's a line that I'm drawing, that's my worst acceptable line. If I go on the worst acceptable line 2, it's going to pass through this point, then it's supposed to, okay, it's a little bit deviated, but it's supposed to pass through this point itself, right? So those are the 2 possible lines of worst fit that I can draw. But remember, you must only draw one worst acceptable line. It's only in the above example where I drew true lines so you can be able to understand. So essentially, you must connect the top right error bar to the bottom left error bar and vice versa if they're horizontal. If they're vertical, what you're doing is go to the top, you go to the top, and then you join this to that, right? And in doing so, all the error bars will pass through the different points. And after that, you'll be able to gain the mark for the line of worst fit because it's going to pass through all the error bars. So essentially, it's a line that shows me the range in which the line of best fit will lie. And I only take one, I don't need to draw both. But this is just so that you can understand, it's a simulation for you to understand how the worst acceptable line concept actually works. So using this example, I got these points and I plotted them accurately. So my line of best fit was basically a line that tried to establish even distribution, right? 1 point over there, 1 point over there, 1 point on the line, 1 point on down, 1 point above, 1 point. Like I'm just playing around and ensuring that there's an even distribution of points above and even distribution of points below. But make sure there are no outliers, right? I want you to draw a graph where there'll be a point that's over there. It's too far away from the line of best fit, right? And because you're being given points, they will never give you outliers. They always try to give you points that make sense. It's up to you to draw a very nice line. If you were to draw a line like this, I'll be like, okay, you have even distribution, 3 above, 3 below, but come on. The lines are too far away from the line itself of best fit. So you always have to make sure that's done. Then for my error bars, as I plotted, you can see that I had plus or minus 0.04, 0.03. That's what I did here. I went here and I was like, for example, 0.2 or 0.03, really, it's 0.2, 0.3, like this. This is a horizontal error bar. A vertical error bar, if it was in the vertical, would just be like that. That's basically it, right? Okay. And then I was asked to draw the straight line of worst fit. Now I'm connecting this error bar. Like I said, I'm connecting this error bar to that other error bar over there, right? So essentially, it's the right top left error bar and then the top right error bar itself. This is one of the easiest marks that you can get because you're just plotting points, guys. You're putting your error bars, you're drawing your line of best fit, and you're drawing your line of worst fit. And by doing so, you'll be able to get all the marks that you ever need. I hope this video was helpful. And I'll see you guys in the next video where we finish off paper 5. Thank you guys for watching.